Steve Higgins from Rolls Battery Engineering. We're going to do this webinar on battery maintenance today. Primarily, we're going to talk about, again, as I mentioned earlier, flooded batteries, importance of taking care of them. We are going to interject comments on AGMs and gels, but the biggest problem we have with flooded batteries in general is people doing the maintenance, like people are looking elsewhere at this point in time. The first thing about the flooded batteries is, what is this? So that's basically the question. In a live format, I would hopefully get some hands and so people would comment. But this is what a lot of our battery customers see, is they see the corrosion on the terminal, and they think there's a problem. Unfortunately, corrosion's not typically what causes corrosion are two things. The number one thing that causes corrosion is customers are quite often overfilling their batteries. The second thing that causes corrosion is loose connections combined with the hydrogen gas that comes out of the battery. When you're charging a battery or using a flooded lead acid battery or even AGM battery, that battery is gassing. An AGM battery gasses at a much lower rate than a flooded lead acid battery, but there is still gassing. And so when it's happening is the corrosion reacts with the hydrogen gas, which is extremely corrosive, reacts with the lead and causes this type of corrosion. Generally, how you prevent it is you put petroleum jelly, which is usable, but petroleum jelly needs to be reapplied often because it's got a lower melting point. Or you put dielectric grease, and you don't have to use a lot. A lot of guys overuse it. You just put a little bit on your fingers, rub it on the terminal, and it should prevent a lot of corrosion issues. As I mentioned, the other thing that causes this is overfilling. This is out of the manual, and what this means is that every battery has what's called a vent tube, and that vent tube, the vent well is this right here. That vent well typically extends into the battery between 1.25 inches and 3.5 to 4 inches, depending on the type of battery. There's a notch in the side of the vent well right around here, and that notch, a lot of people think that the water level has to go into that notch and then at the top of that notch. What ends up happening is when you're charging those batteries, the water expands, or the electrolyte expands, and it pushes out of the battery. That's not a good thing because it does two things. It causes corrosion, and it also dilutes your specific gravity. It's not going to dilute it. It's not going to dilute it to the point where, if you do it once or twice, but if you do it over the lifetime of the batteries, you're going to start noticing your specific gravity is dying off. So it's very important to make sure that your electrolyte levels are 1/2 inch to 1/4 inch below the bottom of the fill tube. One of the things I'll use is I'll take a plastic dowel or a pipette I use pipettes for my refractometer. I'll take a couple of pipettes and mark them with electrical tape to where that fill tube level should be. And the little LED flashlight, I'll shine it into the battery, and measure basically like a dipstick into the battery. It's one of the quick ways to make sure you got a good level of electrolyte. All right, so next slide we have, there we go. This is an actual email from a customer a few years ago, and it highlights one of the things you should always do before you do any kind of battery maintenance, and it's why inverter companies manufacture and sell or put into their AC distribution boxes a bypass switch. It's the #1 reason for a bypass switch. What happened was that this customer didn't shut off their loads, didn't shut off their sources, and while in an attempt to clean the corrosion off the terminals, he took out his grinder and started grinding the corrosion off the terminals. But unfortunately, because the batteries were still gassing and they were being charged, that ignited the hydrogen, which caused the battery basically to blow apart. This customer is very lucky he didn't get hurt, and it's something to keep in mind when you're doing maintenance, that you should always do the maintenance with the system shut off. You should always wear always wear safety gear. Couple of the tools you need to do maintenance. It's always nice to have a coworker with you in case you make a mistake. If you don't have a coworker, then you make a mistake, and it's typically not a good thing. Having gloves, safety glasses, if you're going to deal with a whole lot of electrolyte, like if you're activating batteries, it's a good idea to have a full face shield, some sort of hydrometer, refractometer, distilled water, a dip spanner, some sort of wrench, so you can loosen connections and retighten. Wire brushes and sandpaper or grinder, as long as you shut the system down to clean posts. Baking soda to clean up electrolyte or clean up spills, stuff like that. So this is basically just a list of some stuff that you should use. I'd also suggest using an acid-resistant apron, just to make sure that you're not going to destroy your clothes. We all have what I call holy pants. They're jeans with holes from the thighs down, leaning over batteries doing maintenance. Not usually the best thing to be blowing through pants that way. Here's some of the pictures of some of the items. These two items that I'm highlighting are, of course, they're not being highlighted, so I'll circle them. So these two things I'm circling. These are electronic refractometers. Unfortunately, electronic refractometers are pretty expensive, and they break pretty easily. So it's something that you're looking $3,000, $5,000, $6,000 for one. To get one of those, and have a guy in the field break it continually, or guys in the field break it continually, typically it's not the best thing to do. I prefer to use a refractometer. Some guys prefer to use hydrometers. I'm going to show you some pictures of those in a second. So as long as I can get it switched. I love webinars. So hydrometers, refractometers. Here's a couple pictures of some common ones out there. I will tell you that this specific hydrometer you can buy at most all automotive stores. The problem with them is that I find is they don't get cleaned very well, and they tend to read 15 to 30 points high. Most often when customers buy those hydrometers and they give me these readings, they're all 1290, 1300, 1310, almost out of the top range. And then when you put a refractometer or a standard bulb type hydrometer on it, then what ends up happening is that the specific gravities all come down. So be careful with those. You want to watch out with those. Otherwise, you'll find issues. Unfortunately, I see it all the time. This is a refractometer. I apologize. The picture's not the best. It's one that I tell people to get. It's off Amazon. It's called the X-Tech RF41. It's a temperature compensated refractometer. I took a picture of the scale that's inside it. Basically, when you're reading it, this is what it looks like. And this is the scale that you're looking for. So it'll measure 1.1 all the way up to 1.4. Typically for Rolls batteries, a good specific gravity would be roughly in that range, fully charged and good. As you can see, it labels the specific gravity as good between 1.25 and 1.4. Again, that is based on all the different battery chemistries in the world. If you're using our batteries in an industrial application, you typically want to be right around 1.255, right around here. And a renewable energy application, you want to be a little higher because of the lack of charging sources. So be sure, no matter what batteries you're using, that you understand the batteries that you're using. So the next one, again, this is a picture of the refractometer that I use. This is there's no testing, there's no electrolyte on the screen, so it all comes up kind of all blue. If I take my refractometer and I put, this is just me doing a test at home on some 1280 specific gravity battery, or battery acid. I take a little bit of electrolyte, not a whole lot, just a couple drops. I drop that on the slide. I close the lid, and I look through the eyepiece. It's about 4 to 5 inches apart. You should be wearing glasses. I've had installers complain that it gets too close to your eye. It's not a whole lot of acid. It's safe as long as you're wearing glasses. You shouldn't run into problems. When I go to look at that, this is what it looks like now. Now I have my line, 12.5, 6, 7, 8. So this electrolyte's a little bit under. It probably needs to be calibrated a little bit. There's a calibration screw on the refractometer that lets me calibrate. I can put standard water in there or a known SG on there and calibrate it. And so that's what a refractometer looks like. Pretty accurate, pretty easy. The one issue is that when you're going through a battery bank, taking specific gravity measurements, you're looking at this, writing down on a piece of paper, with anything, if you're stopping to write, it typically it makes things more difficult. One of the things I suggest is that, and one of the things that I use is I carry around a little portable digital audio recorder, and I set it in the battery room with me, or I put it in my shirt pocket and set it to record, and I just say battery 1, cell 1, 1.26, cell 2, 1.27, and that way I can just verbally talk to myself as I'm going through the battery bank. It looks a little strange to your customer when he walks in halfway through and you're just talking to yourself, but it's a quick way to take care of those measurements, and then you can go back and play it and write down the measurements or log the measurements into his log form without having to stop every single time and take measurements. One of the other neat little things out there, and Midnight Solar sells it, is this Hydrovolt hydrometer. It's kind of cool. It's a box type hydrometer. The nice thing about it is it doesn't allow bubbles to form, so you don't have to shake out all the bubbles. The other thing is no matter how you tilt it, it reads relatively accurately. So one issue that I found with it is that the straw that goes into the battery is probably too short for more serious batteries. So what I did is I bought some PVC tubing from Home Depot or automotive store, and cut a 6 or 7 inch long piece and used that to do it. It changed the specific gravity reading a little bit because it changed the volume of electrolyte in the hydrometer. But as long as you know that and understand that, you can easily make mental adjustments to make sure that you don't have the problem. One of the issues that you find, and I'm going to show you a couple pictures here, what I call my "come on man" really pictures, is this is a specific gravity test from a set of batteries that I did in Europe, and took a picture of it. What is the problem with that? Your electrolyte should never be dirty, should never, your electrolyte should never look like this. And the problem with this is this tells you, with the way this electrolyte is going, is it tells you that the active material is coming off the plates. Either the batteries are getting too hot or they're being cooked. There's a lot of things that could be a problem. In this case, it's on an island off the coast of Portugal, and the electrolyte's the batteries are getting in the 50, 55 degrees C temperature range all the time, and it's literally cooking the active material off the plates. You do not want to see this. As the batteries age, you'll see little flecks sometimes, but it should be relatively clear like water. Here's another one that I picked up that I saw in Oregon. Same thing. These batteries were installed outside on the west side of the house, and they were basically being cooked. The cover was a piece of plywood, so not the best, cleanest location you want to be at. So generally, most common causes of failures with batteries: improper charging. I would say of the folks that I talk to on the phone, 95 to 99% of them are not charging the batteries at a proper voltage. Either the PV array has been underestimated, either voltage is wrong. A lot of people are still using default settings of 57.6 or at even 58 volts. And absorption times. A lot of the charge controllers have NDAMP settings in them now. That's usually defaulted at 1 or 2%. Typically, I like to see the NDAMP setting for Rolls batteries about 1 to 1.5%, and then, or you to complete a full absorption time, and without having a NDAMP setting set up. Second possible most common cause of failure is watering. Typically it's underwater. Typically it's overwatering. Underwatering is let the batteries dry out. When they dry out, you expose the plates to oxygen. The plates oxidize and you lose capacity. Another one of my favorites is incorrect water. And I'll get into that here. Oh, actually, I'll get into that in a second. Is not using the correct water. Distilled, deionized water, reverse osmosis water is what you'll use. You want to around 7, but you want less than 5 parts per million of dissolved solids. Anything more than that, you're going to start causing damage to your batteries. Then, of course, we got loose or dirty high resistive connections. When you develop a loose connection on a battery terminal, that develops resistance. As you run current through that resistance increases the heat. The heat causes the connection to melt. That picture, for example, that is a high resistive connection. The cable looks like it. The connection looks like it's good. It's a bus bar, but unfortunately, what happened was it got so hot that terminal melted. That melting, what you want to do is, we'll talk about it here a little bit later, is about once every 9 to 12 months, you want to go and you want to back off that connection, quarter, half a turn, full turn, and then retighten or retorque. And the reason for that is that when you have a stainless steel hardware and you have a lead terminal, and as those terminals heat up and cool down, they're going to expand and contract at different rates. So they're naturally going to back off, regardless if you used a lock washer or anything. Get rid of my drawings. And then, of course, corrosion. Corrosion's an issue. We talked a little about that already, but I'm going to show you a couple more pictures. Here's one that is Zeeman Rolls battery. This is a corrosion from a Trojan battery. If you look, the top's the top is covered with either baking soda or most sulfate, or it's corrosion from the hydrogen. If you take a voltmeter and you put your voltmeter, your negative here and your positive here, you're probably going to get voltage. That means probably over batteries. So, and of course we saw this picture a little earlier, just to highlight it. And one thing to note on this picture, if you notice, if you look right in here, the black silicon RTV is missing. And so if you see that, then what's happened is that corrosion has eaten that silicon apart, and that means that the corrosion's probably moved inside the batteries. On this particular battery, it's a Series 5000 battery. I think it was a 4KS25, if I remember correctly. You can pull that red top off and get inside there, and you've got to also clean the bus bar connections inside, because if you just clean this up, patch up the silicon, that corrosion is going to continue to grow like a cancer inside the battery, inside the connections, and eventually you're going to have failure on the internal connections also. You do not want that. So next thing, all water is not created equal. I've had dozens of people call me up and say, yeah, I use the water. I've got a window air conditioner, and I put a bucket underneath it, and I just collect the water off the air conditioner, and that's what I use to fill up my batteries. Dozens. In Africa, typically in Africa, what they do is they get whatever water they can find: tap water, lake water, river water, stream water, whatever, and they top it off. The same thing happens in Latin America. Not all water is created equal. So a couple months ago, or about a month ago, I decided to do some checks. And so your enemy when it comes to watering flooded batteries is total dissolved solids. Again, you want less than 5 parts per million. One of the things I did is I went out and bought a couple of meters, a pH meter and a total dissolved solids meter. If you want links to them, I can send you links to them. I got them off Amazon. I think I paid $20 for both. $20 total. Take these and you throw them into. I went to Safeway and I bought some drinking water and some distilled water. Bought the same brand. If you noticed, I took a total dissolved solid meter and I tested it. 24 parts per million on drinking water. So if you're buying drinking water and you're topping off the batteries with that, now you're putting in 24 parts per million dissolved solids into that battery. That battery is going to slowly fail. Notice our pH is a little high also, 8.6. So something else to look at. We do the same brand water in distilled water. That same brand distilled water, total dissolved solids, 0. That's perfect. That's what you want. Unfortunately, I didn't have any RO water or deionized water to go play with, but your pH and then your pH a little high, 7.7, but it's workable. You know, so that could fall within the. I haven't played with the meter too much, but I did play with the TDS meter quite a bit to see what kind of settings I would get. So that's what you're looking at. And last but not least, one of the things I did is I took my tap and I took my drinking water out of my tap. I live in the Pacific Northwest. My pH was 7.8, while my total dissolved solid was 25. And so, again, not all water is created equal. You really need to use distilled water, ideally, to be able to top off the batteries. A lot of folks, if you're going to use drinking water or tap water, basically you're killing your batteries and you're voiding your warranty. A couple of solutions. There's a company by the name of Philadelphia Scientific that makes a deionizer, or actually a reverse osmosis machine. On Amazon, they're about $700 to $900. They also make portable fill stations and watering guns that you can set up. You know, they're kind of expensive. If you have a high-end customer who needs a watering application, it's a decent company to buy from. The way I usually do it is I will tell customers go to Lowe's or Home Depot or a hardware store, and I'll tell them to get a 1 or 2 gallon weed sprayer and fill it with distilled water, bottles of distilled water. We'll have them take this nozzle off, so it's not a spray nozzle. Some of them have flow nozzles and spray nozzles that you can adjust. Some of them are just straight spray nozzles. I will have them take this nozzle off and tell them to use this to fill their batteries. All you do is pressurize it. You put the probe in the battery. You hit the button. It sprays into the battery. You stop the spray when it's done. Very cheap, very easy. $20 for a 2 gallon. That's at least in the U.S. My guess is depending on where you're at, it might be a little more, a little bit less. I got to delete that. All right, so back to this. Most common cause, of course, frayed or damaged cables can also be a fire hazard. Something to watch out for when you're taking care of batteries. You want to make sure your cables stay in good shape, good condition. So when you first install a battery bank, ideally for the first 6 to 12 months, you want to make sure that the batteries are seeing a full 100% specific gravity charge every 14 days. I worked for inverter charger manufacturers for 17 years before I came to work for Rolls. Do not trust their readings unless you can compare them. If you do, typically that's where customers get themselves into trouble, is they go out and they wholly trust their readings, and next thing you know, 2 years down the road, batteries are not operating like they did the first year. By then it's a pretty tough fix. So just tell the customers, tell your end users, every 2 weeks, spot check the specific gravities, make sure you're getting 1265, 1275. If you're not, then you need to make adjustments to your charging settings, either your voltage or your times, to ensure your specific gravities get the capacity. Check the water level, regardless of the battery type, every 30 to 45 days. And you want to do this to make sure they don't run dry. If you're in cooler climate environments, Alberta, Ontario, the provinces of Alberta, Ontario, you're not going to use as much water as if you were in Cabo San Lucas, or if you were in, a hot, dry climate like the Sahara Desert, or if it's an average temperature of 25 degrees C versus 45 degrees C, you're going to use up a lot more water just due to the basic evaporation. So you want to make sure you get to learn your battery, because every battery bank is different. Every customer site is different. I've installed batteries, you know, just down the street from each other from locations, and one customer has to top his batteries off every 30 days. One customer can go every 90 to 120 days. So it varies, and the settings are different. So that's something that don't go into it blindly thinking that everything's going to be the same because you put in the same system. Everything's not the same because the customers are always different. So keep that in mind. 13 months to end of life, depending on the type of batteries. You know, make changes in charging voltages, time settings based upon information that was gathered the first year. Typically, you're going to have 2 or 3 adjustments a year depending on your weather. I would spot check the SGs every 60 to 90 days. Normally what I do on my banks is I'll label the cells, even or 1 through, say, 24 cells in the bank, 1 through 24. I'll have the customer check the even numbered cells on the even number months and the odd number cells on the odd number months. You don't have to check them all, but if you do that at least once every 60 days, you have a full specific gravity recording. So if you start seeing problems, you can address those problems before you have a failure, because if you address them after you have a failure, you could be harming the other batteries in the battery bank. So especially as the battery ages, the more you pay attention to it, the better you are. One of the things to look into is, for example, AGM batteries and gel batteries, you can't check specific gravity. All you can really do is check the voltage. So one of the things that you should do that I talked about last month was you should plan at least once a year to go out to the site and do a load test. Put a 10-hour discharge rate load test on the batteries and see how those batteries are operating. That'll give you a good idea of what the battery condition is and if your charging is working properly. If you have an AGM or gel battery, it might be a good idea to put a load on the battery at 6 months to see if the batteries are responding to the charging you're doing to them. Just an idea. I know it's a lot of labor, but sometimes the extra labor you put into it's going to pay off in the back end. So generally, every 45 to 90 days, measure and record resting and loaded voltages. If you can try to get them as unloaded as possible to get you an unloaded reading, and then you can measure loaded voltages, typically at a C10 or a C20 discharge rate to give you an idea. Check and record your electrolyte levels, specific gravity measurements, ambient temperature of the battery room. It's a good idea to make sure that the battery temp sensors are working properly or they're properly attached. You know, battery temp sensors should be on the side of the battery, the hottest location of the battery bank, about a third to a half the way down the side of the battery. If it's a double-sided sticky tape, run some electrical tape or duct tape around the battery to hold the temp sensor to the side. If it's a Series 5000 battery, you could even pull the top off of that battery, notch the side of the battery, and drop the temp sensor inside it's going to work better inside. Matter of fact, the new manual has instructions how to do that. We just put that in recently. And of course, top off with distilled water is necessary. Every 180 days, test your ventilation. Make sure that your ventilation is good. Check for high resistive connections. You can do this. I prefer to do it about every 6 months. Realistically, when you're checking connections, every 9 to 12 months is really when you want to do it. I like to do it every 6 months because I don't want to get in trouble with a loose connection. Verify the charge output of the various chargers you have. Make sure that put a current meter on them to make sure that they're actually truly putting current to the batteries. Sometimes when a charger fails, it's not failing, or it's not charging the batteries because there's no current flowing. Voltage maybe, but maybe there's a set drive or something causing a problem. Check your grounding connections. Of course, check evidence of leakage, especially in the spring, which we'll do a spring one here a little later. So generally in fall maintenance, some of the issues we run into with fall maintenance right now is there's really, if you've seen any of my presentations, there's really 3 different types of systems. There's the off-grid, the weekend seasonal guy. He's there for 3 months of the year, 4 months of the year. He closes the cabin up, drives away, and comes back in March or April. There's the off-grid full-time folks. Those are the folks that live fully 100% off-grid, and of course the grid-connected backup folks. The number one problem for the off-grid or weekend or seasonal folks is freezing, and especially with a flooded battery. A battery at 1265 or greater specific gravities won't freeze until the temperature is negative 92 degrees Fahrenheit or negative 69 degrees Celsius. I hate to read that directly, but that's the truth. If you keep your batteries charged, you won't have a problem with freezing. At a 1220 specific gravity, those batteries will freeze at 20 degrees Fahrenheit or 6 feet. So if they're mounted under the house or in the garage, and you spend, if you're in Saskatchewan and you, and I apologize, probably just murdered the area. If you leave your batteries in a discharged state for a long time, they will freeze. And if they freeze, what happens is the water expands, it pushes the plates together, and it causes shorts. So one of the things to do for off-grid or weekend seasonal cabins is you have to isolate all your loads. Make sure the only load on that battery bank is the charge controller, okay? Or if there's a refrigerator or something that has to run, like a camera system, make sure it's either running on DC direct off the batteries, because that's going to be the most efficient. Or if you've got to run the inverter, you have to have the panels to be able to provide the power, and those panels need to be optimized to maximize your PV production. Which means if it's a pull mount system, you've got to set the panels up, 4 to 6 feet above the highest snow level. You've got to angle the panels at 70, 80 degrees, even 90 degrees to make sure that the snow falls off the panels. If you don't do that, and the panels get covered up with snow, and it spends, 20, 30, 40, 50 days, or even 2 months at a low specific gravity with very cold temperatures, those batteries will freeze. I've even seen AGM batteries freeze, and it's a possibility they can freeze. And typically when they freeze, you're looking at extended times below negative 40 C. So I had a customer install some AGM batteries on his porch, left the house alone for 6 months, shut everything off, didn't charge at all, and the AGM batteries froze. So, expected. So also the nice thing about wind generation is typically customers have wind in the summertime, or I'm sorry, they have wind in the winter, but they don't have wind in the summertime. So even a small wind generator will help if you have a decent wind profile. So just an example of what freezing looks like. This is what it looks like. Water's expanded, it's pushed the plates out, and the batteries have basically busted out the sides. Again, this damage is not covered under warranty because it's not a manufacturing defect. I got my slide a little screwed up there. So loss of capacity for off-grid for seasonal cabins. A lead acid battery basically lost capacity. It's one of the number one causes, number one issues. Lead acid batteries like to cycle, so if they spend 4 months just kind of floating off a PV array, you're going to lose a little bit of capacity every winter. And to gain that back, what you do is you instruct your customer that when he comes back, run the batteries through a full absorption charge. If you have a specific gravity difference of more than 25 to 30 points between the cells, do an equalize. It's going to take 5 to 10 cycles for those batteries to regain capacity. So have them be patient with it. When the first month, the batteries should come back. The next issue would be your connections. Again, don't just do a tug test on the cables. Because if it's already loosened up or welded, the tug test isn't going to detect it because it's going to look like a good connection. You've got to go up, put a spanner on it, loosen it, retighten it. If you don't do that, you're gonna end up with a melted connection. The next one's off-grid full-time homes. Freezing is not usually a big issue because the customer's there all the time and the customer's using the batteries. So the batteries will generate, while under use, they'll generate heat. And so that's the great thing about it is an off-grid full-time home typically won't have freezing problems. Again, put the information there in the freezing. Deficit cycling is probably a big issue with these types of systems, because what happens in the wintertime? I mean, I live in the Pacific Northwest. From October to June, we see cloudy skies pretty much during that time period. So PV arrays are greatly reduced. You're going to see a dump in how much power, but then often your power consumption goes up, especially if the customer's heating with electricity instead of propane or a lot of these customers will burn wood to heat. So expect a distinct loss of renewables, and expect to run the generator. If you've sized your PV within the 10 to 20% of the C20 rate, I would expect to run the generator 2 or 3 times a week for a full absorption charge. If they don't want to run their generator, they're going to have to design their PV generation, or they're going to have to add some sort of wind generation, some other renewable source to help improve those times. And then, of course, grid-connected backup homes. The number one problem with these, with lead acid or lead antimony batteries, which most all of our flooded batteries are lead antimony type batteries, is they love to cycle. They don't like to sit at a float charge 7 days a week, 365 days a year. And so what you want to do is these systems instruct the customer every 60 to 90 days, shut off the PV input, shut off the grid input, let it cycle for 2 or 3 hours. Use those batteries for a couple hours, discharge the batteries, and then reconnect everything and let it recharge. Do a 15, 20, 30% cycle periodically, and that'll help the lead antimony batteries exercise, for the lack of a better term. So you want to try to avoid that. If you have a grid connected backup home, the best batteries to put in there is a flooded calcium, a AGM, or a gel type battery. They can sit and float forever and not have problems without having cycling issues. Lead antimony batteries, they like to cycle, they like the exercise, and so when you're not cycling them, they will lose capacity, and so it's a good idea to manually cycle them. Unfortunately, many of the inverter manufacturers do not have a auto cycle feature for this yet. I've been talking to a few of them, trying to get it developed, but at this point it's vaporware. And of course, another issue is connections. So typically these systems sit unchecked for months and months and months at a time because it's not important until the power goes out. Power goes out once, twice a year. So make sure you have the customers put a tool on them to make sure that they're properly snug and tight. So again, some battery maintenance falls, things to do. We've already talked about all this. Record the settings. The more information that any battery company has on history, the easier that warranty and taking care of, if there is a warranty problem, that it is. Typically, most companies, if you've got the information, the customer's taking care of the maintenance, it's not going to be an issue. The best example I have of this is a lot of people, you go out and buy a brand new car, the manufacturer tells you to change the oil every 3,000 to 5,000 miles. If you don't change the oil for 2 years and you try to take it in after the engine blows up, the manufacturer is not going to cover the warranty because you never really gotten rid of the shavings that are in the oil as new. The whole purpose of those oil checks are to make sure that the engine isn't going to fail on you. So same thing with batteries. Typically the way the battery fails is it fails over a period of months, not days. And so when a battery fails, you'll see that in the specific gravity reports as they age. So again, deficit cycling, sulfation, loss of capacity. Deficit cycling in general is very common. Need to make sure, depending on how heavily they're using the batteries, you want a full charge every 10 to 30 days. If the customer is cycling it, if they're doing a cycle once every 4 or 5, 6 days, they can go longer between full charges. If a customer is heavily cycling every single day or every other day, they're doing a full 50% cycle, you want to get that battery up to a higher state of charge because it's going to last longer. The more time it stays at that 80, 90, 100% state of charge and cycles, the longer that battery is going to last. As installers have got to educate their customers. Either they have to get the customer to buy in to do the maintenance, or they have to sell the customer a maintenance plan every 6 months to come out and follow up and check every, I've got clients that call me up constantly, want me to come out and service their batteries because they don't want to deal with the acid. That's fine. But generally you want to make sure if you're an installer, you're leaving money on the table by not selling a maintenance program. You should always offer a maintenance program to the customer. You can get to the point where you're employing a couple guys to drive around and do maintenance. It's very important. You got to educate your customer about your system. You got to teach them where the disconnects are. You got to teach them how to start the generator. You got to teach them to program the mate, to program the BMK, to program the Schneider equipment. Because if you don't, what's going to happen is on Sunday afternoon, while you're enjoying your family time or watching the game, they're going to call you up screaming and yelling because there's a problem and you didn't educate them properly. I get calls every day from customers who say, yeah, the installer installed it, drove away, collected the check, and drove away. I never saw them again. Don't do that. If you do that, you're leaving money on the table and you're just making it more difficult for everybody else down the road. Of course, you must invest in sufficient renewable energy sources or burn fossil fuels to supplement batteries. If you decide to put in a 1,000 amp hour battery with at 48 volts and you put in a 2 kilowatt PV array, that customer is going to run his generator constantly to keep those batteries charged. If he doesn't, the batteries are going to go dead. We got a call this morning from a gentleman who has 800 amp hour battery bank or two parallel strips, so he's got a 1,600 amp hour battery bank on an array that's only capable of delivering 40 amps of current, which means that the absorption time, you're looking at 10, 12 hours of absorption time. Unless you're in geosynchronous orbit with the sun, you're never going to get that kind of renewable production, and the batteries will go dead. So be cautious of that. You want to watch out for that. Sulfation's a natural occurrence. You take your battery, you disconnect it from the charger, it starts to sulfate. Don't panic when a battery manufacturer, regardless of who it is, tells you your batteries are sulfated. Batteries get sulfated when they become discharged. It is cheaper to replace water than it is to replace battery. So gassing, batteries are going to bubble, they're going to gas. The gas that's coming out is hydrogen and oxygen. You put back H2O to fill the battery back up. Gassing is okay. When the batteries aren't gassing, that's usually an indication of undercharging. End amps, return amp settings from stated charge meters can exacerbate sulfation. If you have a battery that's sulfated, disable your end amp setting and your return amp settings and force them to do a full absorption or a absorption plus 1 or 2 hours. If you fully depend on those end amps or return amp settings, it's just going to be like flying a plane through a cloud, not paying attention to your horizon meter. Eventually, you're going to end up upside down and nose into the ground. You want to, because what will happen is that as the batteries become more and more sulfated, they'll accept less and less current. And so when that current drops below your end amp settings or return amp settings, the stated charge meter will report the batteries are fully charged, and then your customer shuts the generator off, or they turn on a bunch of loads. So be careful with that. And of course, loss of capacity, usually related to lead-220 batteries being in float, but it happens in cycling applications, usually when the charging settings are too low. Again, lead calcium batteries or gel batteries are best suited for extended float applications. So we're 47 minutes into the webinar. My next webinar is going to be a fun one. I'm planning on doing it on October 13th between 10 and 11 Pacific Daylight Time, 10 and 11 Pacific Daylight Time. We're going to do it on GoToMeeting. I think this was pretty smooth. Hopefully everybody listened. Hopefully everybody can hear. We're going to do this on battery charging. I might even split this one up into 2, depending on how many slides. I'm still working on tweaking the slides a little bit. This one's going to be talking about basically taking a battery bank size, and setting up the chargers. We'll probably focus on a couple different manufacturers for their charging and some of the issues that go on with them. I will send out emails, invite emails, probably in a few days, or probably about a week. So at this point in time, if you have any questions, the chat's still open. I haven't got a question, so either I'm boring everybody to death, or either I've dazzled your brilliance, or one of those things. If you have any questions, I'll hang out and see if there's any questions. My contact information is, again, here's my contact information. If you have any questions, you can also email me directly if you don't want to post it in the chat. Once this is finished, I will put this on. This will also go on to YouTube, so if you want to review it again, feel free to. Thank you very much. I appreciate everybody coming.